y equals a x minus p squared plus q is called the standard form of a quadratic function. When a quadratic is written in this form, there's a lot of information we can get at just by looking at it. So here we're just going to describe the information we'll find. And the first thing we're going to look at is if a is less than 0, then the parabola, which is our graph, is upside down. So usually we call that a reflection in the x-axis. But essentially, it really just means the parabola is upside down. Otherwise, what a does is a controls the shape. And when you play with a values, you often think it's getting thinner or fatter, but what it's actually doing is it's stretching it vertically or squishing it vertically. So a is actually a vertical expansion or compression. And it is the hardest one to kind of see what's going on is with the a value. So when you have a normal parabola or the typical parabola, there's always so much that you move from the vertex and then so many up or down. So with a typical parabola, when you go 1 to the left or 1 to the right, you move 1 up. When you go 2 to the left of the vertex or 2 to the right of the vertex, you go 4 up. If you go 3 to the left or 3 to the right of the vertex, you're going to go 9 up. If you go 4 to the left or 4 to the right, you're going to go 16 up. So what happens with the parabola is you can see it's always just however many to the right or left of the vertex you move, you square that number and that's how far up or down you go. So if you remember this pattern, how a works is a just multiplies all of these values up or down. So if I go 1 to the right or left and a doesn't equal 1, then I'm just going to go 1 times a, which is a, up. Or if it's a negative, I would go down. If I go 2 to the right, normally I go 4 up or down, but if there's an a value, I times it by a. 4 times a is 4a, up or down if it's a negative. Same thing, 9, I would just go 9a up or down. 16, 16 times a up or down. If it was 5 to the right or 5 to the left, then I would go 25 times whatever a is, up or down. So that's the nice thing about a, it kind of gives us our shape. So the bigger a is, the skinnier it gets because it's stretching, because you're going up so much, so fast. The p value and the q value basically work together. P and q give us the vertex. So it's always, what you always have to remember, because it's x minus p squared, but then when I write the vertex, it's just p, it's not negative p, is that the vertex, the x value is always opposite, and the y value always stays the same. So if it's x minus p squared, the vertex is p, so it's opposite. If it was x plus, so say it was x plus 3, then the x value of the vertex would be negative 3. It's always the opposite of whatever's in the brackets for the x value, and then the y value is always the same. So if we were graphing this, this is kind of what it would look like. P is somewhere on the x-axis, and q, there's my vertex. Then I would just move 1 to the right, 1 to the left, a up. Gives me 2 more points. Then 2 to the right and 2 to the left of the vertex, and then you would go 4a up. Usually this is about all the points that you're going to be able to fit. But if you need to, and if you want to, you can always go 3 to the right, 3 to the left, and then 9a up on both sides. And then we just sketch that parabola in. So anytime a parabola or a quadratic is written in standard form, we can always graph it this way really quickly.